The first section is on areas of a polygon, okay? So this is chapter 5, section 1, 5.1. So we're going to start out with a fairly simple figure. We're going to look at a rectangle. So here's a rectangle. And a rectangle has a base and a height. And if we want to figure out the area of a rectangle, we'll call this B for the base. This is the base. Let's say this base is 6 centimeters. And it has a height. And let's say the height is 3 centimeters. And let's go ahead and let's divide this up so that this is roughly sort of separated into 3 equal parts, and let's see, I'll make this sort of rough grid here, not exactly perfect squares. I did it rather quickly. Let's straighten it out a little bit. And so if we look at it, if we say this is 6 by 3 centimeters, then when we find the area of this rectangle is equal to the base times the height, which means the base is 6 centimeters times a height of 3 centimeters. And 6 times 3 is what? 18. And what are the units? Centimeters squared. And they're centimeters squared because if you think each one of these squares is 1 centimeter square, and if you add them up, you should have 18 of them. It's pretty easy with a rectangle. We're in pretty good shape. Most of us learned that earlier in our math classes, right? So let me add a page below. And one that I think you also might be familiar with is finding the area of a triangle. Okay, so here's a triangle, a random triangle. I don't want it to be anything special. It's not. I'm trying to make it look somewhat scalene, but not isosceles or equilateral. Here we go. And when we're trying to find the area of a triangle, does anyone know the formula for the area of a triangle?
Yeah, Ben.
What is it, Ben?
Half the base times the height.
That's right. The area of a triangle is 1/2 the base times the height. Now a triangle can have up to 3 bases, right? So in actuality, we could figure this out 3 different ways. So let me resize this. I'm going to grab this and I'm going to resize it because I want to have 3 triangles on this page. So I'm going to resize this. So let's see, make it a little bit smaller. There we go. There's one triangle, and I want 3 of them. So here's one, and I'm going to copy it and put another one here, paste it. And hopefully I'm going to fit these, and I'm going to put a third one on. And we're going to look at different information that we might have. We have to have the height and the base. So I'm going to put the height and base in red. And for the first triangle, well, each triangle, I can flip it around, and there's a possibility of, there's 3 possible bases. So the first base is going to be base AC. So if AC is the base, the height is when you drop from the vertex B down perpendicular to AC. Okay? So this gives us, let me move that over a little bit. This is the height. So here's our base, and here's our height. And the height is also known as the altitude. It's the altitude of the triangle. So the area is 1/2 base times the height. Now let's look at another case. This is the simple one. We can see it right away. But what if this is our triangle? So here's a different triangle. And what if the base here is BC? All right, let me straighten that out a little bit. So the base is BC. There we go. The altitude then, move this over a little bit, is A to BC, like that. There's the altitude. And so this would be right. It's not perfectly right, but imagine it is. So this becomes the altitude, or our height, and this is our base. And then finally, our last triangle, here our base would be AB, and we would go from C down to AB. And there are cases, however, where, okay, so this is our height and this is our base. There are cases where we have to actually extend our base to find the altitude. And we want to be prepared for that, okay? So let me add a page. I'm going to add a page below, and I'm going to put in a triangle in which we have to extend our base, okay, to find the area. Okay, so let me see. I'm going to make this an obtuse triangle. Here we go. That's an obtuse triangle. Now, this is triangle, let's say ABC. And what if, in fact, we want our base to be BC? What if our base is, we decide, well, the base I have happens to be BC. It's a little thicker here. If BC is my base, I have to extend that base to find my altitude, because the altitude has to come from A. And if I try to reach A down to BC, it's not going to be perpendicular if it's inside the triangle. So what I'm going to have to do, let me move the triangle down a little bit. It's going to disappear for a minute while I move it down. Okay, and I want to, let's extend BC. Here. So I've, actually, it's not really lined up. Let's see if I can extend it a little bit better. I think I can. Let me take it. Yeah. Let me just take it like this. I think I can copy it and paste it, and I'll have it collinear. So I want to, so there's my extended base, okay? So now I've extended the base, and just to indicate that I extended it, I'm going to dash it, because it's an extended base. And now I'm going to go from A and drop down perpendicular to my extended base. We have to be careful with this type of situation, because look, my base is the length of BC, and my height, or my altitude, is here. So you have to determine that, okay? So don't be fooled when you have a base and you have to draw the altitude, and the altitude doesn't drop down to the base within the triangle, okay? The area is still 1/2 the base times the height, okay? So we've got a rectangles, triangles. Now let's look at a parallelogram, finding the area of a parallelogram. So let's draw the parallelogram in black. So here's one side of the parallelogram, and there's another side. And let me copy the first side and paste it. And then the second side I'm going to copy to paste it, just to make sure that they're parallel and the same length. There's our parallelogram. Let's zoom in on this a little bit. All right, make my font not quite so thick. Okay, so this is parallelogram ABCD. Now, the area of a parallelogram, the formula for the area of a parallelogram is its base times its height. The question is, what's the base and what's the height? And in a parallelogram, there are actually 8 possibilities. And so I want to look at the 8 possibilities. So let me grab this. I'm going to copy this, because I'm going to paste it 3 times. Before I do, let's do a simple case where you pick which side will be the base. There are 4 possibilities. Okay. Your base could be DC, and if DC is the base, then the height is we drop from A down perpendicular to BC, and so this is our base, and this is the height, which is also considered the altitude, okay? So that's the area of a parallelogram. This is, let's just indicate that it's a parallelogram. These 2 sides are parallel, and these 2 sides are parallel.
On a rectangle, is the height altitude?
Yeah, this is the same formula as a rectangle, actually, base times height, isn't it? But we've got to determine the base and the height, all right? So this is for a parallelogram. So let's look at the different possibilities, though, because it's not always clear-cut as it is in this case. Let me move this down to the center, and I'm going to open up another page where I'm going to show 8 different cases. Okay, so I'm going to add a page below, And here's our parallelogram. And I'm going to copy this. I need to shrink it so it's 1/8 of the page because I want to show all cases. Let's see if I can. All right, so there's one of them. I need 8 of these. Let me copy this and paste it. There's another one. And now I'm going to need, let's see, 4 sets of 2. Let's see if I... And now I need 2 sets of 4. I'm going to look at them one at a time. Now, in the first column, I'm going to have my bases be, well, let's see, for the first one, I'm going to make my base be DC. And the second one, it will still be DC. And the last two, the bases will be AB. And notice that AB and DC are the same. So for the first column, all the bases have the same length. The second column, I'll have the first two have a base of AD. And the second two will have a base of BC. And notice in the second column, the bases all have the same length. Okay? So if I look at this first one, the base is DC, and I'm going to drop 2 DC from A. Oops. I went into eraser. Perpendicular. There's the altitude. Okay? Now for the second one, I'm still going to DC, but this time I'm going to drop from B, which means I need to extend DC. And let's dash the extension because it's not part of the base. It's just extended. And I need to drop from B down to the extended base perpendicular. Oops. Okay. And the next one, the base is going to be AB. Notice all these bases are the same. And so from this one, I'm going to go from C up to AB. And that's also an altitude. And the next one, I'm going to go from D to AB, but again, this is another case where I have to extend this base. And so the extensions we dash, and I'm going to go from D to the extended AB. So there we have our first sets of bases and altitudes, okay? Now let's go to the second set of bases and altitudes. If my base is AD, it looks like this AD kind of came off a little bit. On a bit better. Okay, so I can go from C perpendicular. So I'm going to drop C down. Hopefully I can get it on there okay. If I go from C and drop perpendicular, imagine that's perpendicular. Okay. Now if I want to go to that same base AD from B, I have to extend. Let me copy this a minute. Copy. Put that. The base is AD. I'm putting it on top. It looks like it slid off a little bit. Okay. So I need to extend base AD like this. And I'm going to make it dashed because it's an extension. And I'm going to drop from B perpendicular to the extension. I don't know if these are exactly perpendicular. I'm trying for perpendicular. Okay. And now if the base is BC, I can drop down to BC from A. Make this probably down here is a little more perpendicular. And then if I drop from D down to BC, I have to extend BC. Remember, this is extended, so I dash it. And I'm going to go from D perpendicular to BC. So I wanted you to see all the possibilities because you're going to be working with areas tonight, and the book tries to trick you. So you want to make sure you wrap your mind around this is a parallelogram. Pick the side you know, that becomes your base. Find the altitude that corresponds to that base, okay? Because the area of a parallelogram is merely the base times height, okay? Okay. So we've got a rectangle, a triangle, a parallelogram, and now we're going to look at the area of a trapezoid. So let me add a page below, and let's throw up a trapezoid. Remember, let's write trapezoid for this one. What's the definition of a trapezoid? Can anyone tell me the definition of a trapezoid?
Any? Anyone? Oh, I know.
Everett, what's the definition of a trapezoid?
It has two parallel bases.
Yeah, it's a quadrilateral, yeah, with two sets of parallel sides. So here's one side, and there's the other. And I'm purposely making it so that it doesn't look isosceles, okay? So this is a trapezoid. It has two parallel sides. Here are the parallel sides. We have, this is side AB, and this is side CD. And then let's put the other sides in. We also have these are the legs, okay? The area of a trapezoid, and this is something that comes up in calculus later when we're working on the trapezoidal rule. The area of a trapezoid is 1/2 the height times the sum of the bases. There's a base 1 and a base 2. So let's take a look at base 1 and base 2 and the height. So in red, there are two bases. Here's one base. Let me make this a little bit thicker. AB is a base and DC is a base. These are the two bases. And the height, well, if we take from A, drop down perpendicular, that gives us the height. So here's the height. Here's our, we can call this one base 1 and the other base 2. And that's how we get the area of a trapezoid. So let me center this, and what I'm going to do is open up another page, because like the parallelogram, the trapezoid can have different heights or altitudes, right? This height is also the altitude. And so we want to be able to identify them. So let me add a page below. And let me go ahead and draw. For this one I need 4 trapezoids. There are 4 possibilities. So here's my first trapezoid. Trying not to make it look isosceles. Okay, so here's our first trapezoid, and I'm going to label the vertices A, B, C, D. And just to make sure we know it's a trapezoid, put in our little identifiers so that they're parallel. And I'm going to copy this, and we need 4 of these. So I'm going to copy this and paste it. And then we need another one. And you have to identify these, because you'll be given certain information and you have to figure out the base and the height. So in our first case, which is pretty simple, the first one, is that if DC is the height. Matter of fact, we'll have 2 with the height of, I'm sorry, DC is the base, one of the bases, or I should say these are, we can call that the base of our triangle, of our trapezoid. And in the second case, I'm going to make AD the base. You actually have 2 bases, so I just have to grab one of the 2 parallel bases. So in the upper left-hand corner, I can drop from A down to DC perpendicular, and this gives me the height. And this is one of my bases. We'll say this is base 2, and base 1 is the one right above it, parallel. The next one, I can drop from B down to DC, and this is the height, and this again is base 2, or base 1 is the one above it. Now, I can also, if I decided, stick with the left-hand side, if my base was AB and I wanted to drop down from C, I would extend AB, and I have another height here, okay? So this is another height with base 1, or I can extend base 1 like this and drop down from, or up from D and get another height. So this is also a height. So I have 2 heights that correspond to base 1, and I have, well, 2 heights that correspond with base 2, right? In fact, I probably should have, let's see, we can move this and put it on the bottom one so the top one's not so busy, okay? So, in fact, all the heights that I just drew correspond to base 1 and base 2, and they're all congruent, right? Now on the other side, if my base is AD, let me go back to red, my height to AD comes down from C like this. Let me straighten that out a little bit. And this is a height. So in this case, my height starts at C, and here's my base. And I can call this one base 2. Actually, I take that back. Big mistake. Let me get rid of this. This is it right here. Let me get rid of that. These are the only possibilities. I was going into parallelogram mode. There we go. There are only 2 bases, base 1 and base 2. And there are 4 possible heights for those bases. And they are all the same. Does that make sense?
Yeah.
Okay. There's one more. Can anyone think of the next figure that I might do? A rhombus. The next one is a rhombus. So let's take a look at a rhombus. What's the definition of a rhombus? What's it, anyone?
Like, it has 2 parallel sides.
All sides congruent, right. In fact, a rhombus is a parallelogram with 2 consecutive congruent sides. And so if I go ahead and draw the first side, here's a side, this is a certain length, and I'm going to give it another side, and these are, I'm trying to make them the same length. There we go, right? And so let me go ahead and they're 2 consecutive. Well, we know because it's a parallelogram, opposite sides are also congruent. So let's see, let me copy this and paste it so this has all sides congruent. Let's put them together. It's a rhombus. It's sort of like a squish square. A square itself is also a rhombus. So this is rhombus ABCD, and I'll make the font not quite so thick. This is rhombus ABCD. Now a rhombus, well, you can figure out the height. You can figure out the area of a rhombus the same way you figure out the area of a parallelogram, right? It's base times height. You can draw the altitudes and pick your base, right? But there's another way to find the area of a rhombus. Let me blow this up a little bit. And that is, I'm just resizing it, it'll come right back. And that is using the diagonals. Let's take a look at the diagonals of a rhombus. The diagonals of a rhombus, they bisect each other and they're also congruent. It's the same thickness. So we have AC, BD, and we know because it's a rhombus, the diagonals not only bisect each other, I'm sorry, they're not congruent, but they're 90-degree angles. They're perpendicular, right? So the area of a rhombus, well, you can use it the same formula as the area of a parallelogram, but another formula for the area of the rhombus is 1/2 the product of the diagonals. Diagonal 1 times diagonal 2. In this case, the diagonals are AC and BD. Okay? So this concludes the first section of Chapter 5, where we're looking at areas of polygons. And what you're going to do is you're going to be given figures in the homework, and you are going to subdivide them into the figures we just looked at: triangles, rectangles, rhombuses, and parallelograms, and trapezoids. And you're going to calculate their areas based on these formulas. Okay?